Yes, then it was time for part 6 in my Commodore 64 Resurrection series. That is my way of celebrating the 40-year anniversary of the Commodore 64 machines. And this time it's something like this we are going to look into. This is one of the 2 dead C64Cs that was featured in my video where I tested the trash-picked Trinitron 14-inch color TV. And I actually picked in random 2 of these machines and both had black screen. So I had to go in and get older C64C for that test, because I had one of these with the old board, not the ShortBoard. But the machine we are going to feature today is our first ShortBoard in this series, and it has, as I said, a black screen, and that's all we know about it when we start. So let's look into that. It is not strictly true that this is our first ShortBoard, but on the last one we just changed the power switch, so we don't count that one. This one has all the keys, but looks a bit battered around the edges. Yeah, this sticker was left on by the previous owner. I will keep it that way. And you can see that this is a machine made in Hong Kong, as most of the C64Cs was, at least at the end. And it also has the 3 fastening screws, not the plastic lips that was on the latest version. As you can see here on this other C64C, that actually is made in Germany. And these plastic clamps easily break off when you try to pry the box open. But this C64 will be the patient of our next video. Yeah, we will just try to dismantle this box and see what we can discover inside. And even if the screws sticks well to the plastic, you have to remember that the plastic is brittle, so don't use excessive force for this. And here you can see the telltale sign that someone has been inside here before and loosened more screws inside. The middle screw is the longer one that was used to keep the board down by the brackets, as we saw in my last video when we dismantled the C64C to get to the power switch. Yeah, and inside you can see that there is a lot of dust, but also some corrosion, and what at first glance seems to be most droppings, but they are not. So we will just continue to dismantle the keyboard and the I/O shield so we can get to the bottom of this. Yeah, and here you can see where the long screw that was in the middle hole of the plastic casing should have been. It should have been used to keep down the bracket on the right side. And it's a lot of dust balls on this main board. So I will just try to pick out the worst of them, and I will give this a good wash afterwards. For me, as an old Commodore 64 repairman, the ShortBoards and the internals of the C64C is quite new. When the C64C was launched in Norway, they had closed down all the small repair shops, and they had centralized the repairs either to some foreign or some of the large repair shops that was left in Norway. And I have done some extensive research on this, of course, to keep me updated and so on, but I have to admit that I don't have much real-time experience in fault finding on the C64C or the 5 types of motherboards that has been in these computers. And this is the one that's featured in this video. This has revision 4 board. I do have another C64C with a revision C board, and I probably have some C64Cs with the revision A and B boards. And those are the boards with the internal color memory. So I was thinking, both for myself and for you as the viewer, I'm going to take a short overview of the differences and what's contained within the C64 shortboards. The layout of the board is completely new, but they have kept all the connectors on the side to be able to fit this in older design cases. But they have moved around on the ships to make the signal paths shorter and to get more real estate placed in a less amount of space. And they've separated the two CIAs, but they've still kept the numbering, so U1 is now actually in the middle of the board, while U2, that controls the user port and data for the IAC serial port, is kept in this area. And you can also see that this is closer to the joystick ports and to the keyboard connector. The character ROM U5 is the same as on all English language C64Cs. This is interchangeable, but they have combined the basic and kernel ROMs to save one chip. They have the memory structure of the latest revision of the longboards, where they have two 4-bit memory chips with 64-bit depth on them, and they have replaced the CPU with an 85, and so they've changed the production process to a MOS process. This chip is totally interchangeable with a 6510 that uses the same voltages and everything, so you can put a 6510 in this board and you can put 85,000 in an older C64. The VIC-2 chip is also a new revision. It uses only 5 volt and not the 5 and 12 volt as the former versions did. And there is no fix to use an old on the shortboard. You can of course modify it by cutting some traces and whatnot, but there is no known or Commodore approved way to fit this new chip in older boards. And an old chip won't work on these newer boards. The U20 MOS 8701 clock chip is actually the same as on the later revision longboards, nothing new there. The SID chip is a totally new model that uses 9 volt as the analog amplifier voltage and not 12 volt as the older SIDs. But there actually is a workaround on the main board where you change CR7 to be 12.5 volt version if you want to fit an older SID. I do think that there are some other capacitor and resistor values that's you don't need to change them, but for best audio quality you ought to. But the biggest difference in this version is the new all-powerful PLA chip that replaces a lot of the glue logic, like the 74, 373, 257 and 258 that handles the address decoding and address bus, and also some of the other inverter and NAND chip logic is contained within there. And on the newer revision A and B boards, this also contains the color memory within, so U19 is not present on these revisions of the boards. And as I said, most of the glue logic are contained within the PLA chip, but there are still some left. U23 handles the reset timer, control key, and the pulse for the time of day clock, and all these circuits are actually new. So this chip, even though it was a similar chip on the old boards, this has totally new functions. And the Q1 cassette motor driver is the same. The U22 7406 also is the same, and it handles some of the same tasks as before, but it also has some new signals going through it. The U2 4066 CMOS analog switch, it has exactly the same function as on the long boards, where it switches out the data bits D0 to D3 for the color RAM to the data bus. And also the U18 4066 CMOS analog switch, it does the multiplexing for the analog paddle inputs on the joystick ports. And this is also the same schematics and underlying functionality as on the long boards. So otherwise, there is no big changes. I forgot to mention U3, the 74 LS08. It also does exactly the same as it did on the old versions of the C64. So I do understand Commodore's need to cost reduce the C64, and they actually have done a marvelous job in that, but they also created one more chip that's obsolete and difficult to get hand of, and that is the PLA chip. And they also have two different versions of this, as I said, without or with the internal color memory. So these chips are unobtainable in today's market. So if you know that you can buy them, it's probably because something else has been scrapped. The shorter signal paths has also done that this machine is probably more reliable and also is less prone to be infected with noise than the older versions. And they also managed to keep the power supply to just have one 5-volt rail and one 9-volt rail in addition to the AC voltage. So they've simplified things quite a bit around that area too. Yeah, on this board I was surprised to see that the character ROM, one of the CIAs, and both the memory chips was in sockets. And of course so was the VIC-2, but I've never seen that one soldered in, even on the newer boards. And the same with the SID chip, it's almost always in a socket. And this board is a revision 4 board, and that's one of the boards with the external video memory chips. Yeah, the date codes on the chips are mostly OT7, but this CIA chip has an 89 date code, so this has clearly been serviced after it was brought to market. And the CIA chips was one of the more common faults, and this as people was changing joysticks and other stuff on the fly. And also static electricity was a huge thing in the 80s and 90s with all the wall-to-wall carpeting. Yeah, black screen often means a faulty PLA, but I don't think that's the reason. We have to look elsewhere, and we can see that this is a PAL version. In this video I will try to do things a bit differently, and I think I will use my Fluke scope meter and direct shots of that instead of the scope pictures that I provided in the earlier video, so that you can see how this will look with a lower quality oscilloscope. The Fluke scope meter shows curves on almost every measurement type, both voltage, ampere and frequency, and it also shows curves on DC voltage. Yeah, before we are starting the curves, we are going to look into the fuse and the power switch to check that there is nothing wrong with the supply into the computer. But both the fuse and the power switch shows good continuity, and we check on both the AC voltage side and the DC voltage side of the power switch. Yeah, I switched the meter over to voltage DC and probe the DC voltages. Primarily the 5 volt, and I do not find any faults on this. The DC voltage 5 volt is 5.85 or something, and that's not going to stop anything from working inside this machine. Yeah, with the scope still in DC voltage mode, I probe around the VIC-2 chip, check the VCC, and I also check some of the data bus lines to see if there is activity, and this looks pretty normal, I think. As you can see, the quality of the scope picture is not bad, but you don't have the same resolutions as you have on the Rigol, and it's also the issue with the slopes on the signals. As you can see, this is ordinary leads I'm measuring with, so you do get some capacitance issues in the long leads that I have here. But this is the original leads for the scope meter, so Fluke has made these cables, and they also did some compensation to make the signals better with these kind of cables, but it's no match for a high quality scope probe on a good scope. I'm going to switch the settings over to frequency so that I will get a frequency reading on the display. It won't change the curves, but I won't get the voltage reading, only the frequency as a digital readout. And here you can see the clock in frequency from the crystal. This is also called the color clock, and we also check the video clock signal. That should be half of the color clock. And here we see the RAS and CAS memory timing outputs on the VIC-2 chip, and they're both double of the operating frequency of the CPU, nearly 2 MHz. And we see the AEC is also ticking as it should on the operating frequency of the CPU. Here we can see that there are some sync on the video signal at least, so I do think that the video itself is ticking, it's only with a black picture. And here we measure the two clocks on the CPU. First, the clock out on pin 39, that is a delayed version of the clock in on pin 1. And both are the running frequency of the CPU, almost 1 MHz. After probing around the address lines a bit, I found one that looks a bit suspicious. A14 is kind of hogged down every other cycle, and I'm not sure why. This could just be a measuring error due to some poor calibration of the scope or some trigger issue with the scope. To test the data bits, I actually decided to give the Dead Test Cartridge another go, but first I just take a quick feel down of the ships to see if anything is burning hot and if I should abort the mission to avoid further damage. And it does actually feel like one of the memory chips are a bit hotter than the other. This could be just normal production differences. Yeah, as we saw, the Dead Test cartridge did give us one flash, and 1 to 4 flashes on this motherboard with only 2 RAM chips is bits 4 to 7, and it's the U11 that is pointed out as the culprit in this scheme. If there has been 5 to 8 flashes, then there would have been the bit 0 to 3 and U10 that has been the culprit. And we have seen before that the Dead Test cartridge is not a dead giveaway, to put it at least. And this is only an indication that something is wrong with this memory chip. But we did feel that it was a bit hotter than U10. So I will give it a go now with the thermometer to see if we actually can measure that it's hotter than the other one. Before we take the temperature, we allow the systems to heat up a bit. Yeah, as you can see, it's 29 degrees, the other chip. And this is 30, 31, it seems. 29, so it's a bit 28, 30. These two, it's a bit uneven. And as a control, we take the room chips and they're about 29. And the same with the CIA. Oh, but here you could see that this is unevenly warm. We have some places here where there are some temperature differences. 31, 34. So this ship probably has a short somewhere, because you have some areas of the ship at the top here where there are 35 degrees something, and you don't have the same with this ship. So there clearly are something wrong with it. Yeah, we will concentrate on measuring the data pins, and there are 4 of them of these chips. And this is one output, and you can see these strange narrow pulses that's coming in here. The raw signal looks okay, so there is nothing wrong with the scope per se, I think. And also the address line seems to be, working okay. This is about how it should be. So I do think we have to do a comparison on the other chip to see how the data bits look on that. Yeah, on U10 this looks more like expected with more and broader pulses, and on U11 we are back to the single square pulses, that's just a needle. So we are going to replace U11 with a fresh new on-shelf part 41464 chip. It's a bit different timing and such, but I do think it will be okay to use in this configuration. I've seen people use from 70 nanoseconds up to 120 on these chips. Yeah, we have to wonder why these chips was socketed in the first place. Is not normal, but it was a socket and we have replaced the chip, so now let's try to see if it boots. Yeah, and it does exactly that. So then we can measure to see if the pulses are more like expected on U11. Then we can see if our theory and praxis is coming together, and here is on U10 and here is on U11. And as you can see, nice fine data bus pulses. So I think we can call this a success, but of course there is no test that is completed until we test with the test harness. So that's what we will be doing now. And as usual, we have fast forwarded to the interesting parts of the test. Yeah, and as you can see, the user port has tested bad. And we have noticed before that when the CAA tests bad, it can be because of a bad connection on the test harness due to corroded contacts on the main board. Yeah, we will just try to clean out the contacts with some isopropanol and some cotton swabs, and we will testing again to see if it was just a mistake in the testing that made this U1 and U2 show up as bad. Yeah, and stupid is who stupid does, as you can see when I spill the isopropanol. Yeah, and as you can see, the first run through went okay, but we will let this run another round to see if there are some intermittent issues. And even though it's a bit premature, I think I can say that this was a success. There at least was no U1 or U2 CIA errors. And the sound test is okay, so I think we have another working Commodore 64C. And we will do some more testing to see if the test we did with the Dead Test Cartridge is accurate. We will just remove the test harness as it won't be needed when we use just the dead test. We will also use the opportunity to do some housekeeping and clean out the cabinet and the main board and the chips on this board and get rid of 30 years of layers of dust. Interestingly enough, when we turn the board over, we see that only the CIA socket appears to be done at a later time. So probably the RAM chips and the ROM chips that was placed in a socket was placed in a socket from the factory. Yeah, I will just clean this thing under hot water and maybe some soap if needed. And as you can see, the result was quite okay. There are some residue left on the PCB, probably from some old resin, so I will just clean that off with isopropanol and a cotton swab. Yeah, everything looks much cleaner now. There are still some corrosion and other stuff, but this is not a picture-perfect restoration. It's about keeping this machine safe for another 20 years before we have to do some maintenance again on it. I will also clean out the cooling paste that's on the SID, the VIC-2 chip and the CPU, as the shield on this machine is used for cooling of those chips. When I place the memory chips back in, I see that I swapped what was U11 to U10 and vice versa. It's no big deal, but we will test it anyway. Yeah, and it seems to be working just fine. And now we will do the final test. I will put the chip that was bad and was in U11 into U10, and then I will do another dead test to see if the diagnosis changes. And here I have to be careful because I have two of the same chips, one that's okay and one that's not. And I have put a little marker on this, but I've seen that it's washed away, so I will make sure that it's have the same black screen symptom before we test. So as you can see, it still blinks one blink, even though the bad chip now is in U10 and not U11. And one blink is one steady blink. If it's been 2 blinks, 3 blinks, 4 blinks, it would be asymmetrical, so it will be fast blinks with a pause between. So we can clearly say that the Dead Test Cartridge would not have given us the same reliable solution if it was U10 that was bad. I will now put the good chip in and see what happens with the Dead Test Cartridge when everything is working as it should. It then comes up with a test screen that tests through memory in a similar manner of the normal harness-based test cartridge. And as you can see, this takes much longer than with the other test cartridge. The other test cartridge makes an immediate appearance of the screen. This might make a more thorough test, I don't know, but we have really tested this computer enough at this point. And without the test cartridge, it comes up to the good old boot screen, and you can see that it comes up all the memory. And then I think it's just time to reassemble and get all the screws in the right places. But we also have to put some thermal paste on the shield so that the chips that is connected to this, and that's the CPU, and it's the VIC-2 chip, and it's the SID chip, gets their cooling. And I give them a push to make them have better contact with the surface of the chip. And then we have to remember the two longest screws are the right and left corner where the thickest metal brackets for the keyboard are. All the other screws that goes into the plastics are the short type. The keyboard connector is keyed with one missing pin, so it should not be possible to put it the wrong way. And the screws for the keyboard are metric 3mm screws. There still are some rust and corrosion on the I/O shield, on the RF modulator and on the cartridge shield, but that won't be a problem as long as there is no corrosion and other stuff on the printed circuit board or otherwise that will destroy this machine. I think it will be just fine. And this time all the 3 screws for the cover are of the right kind. Yeah, we do one final test of the machine with the pole position game cartridge. and it's just to check that there are no hidden artifacts or other things that's in the graphics or memory or other things. But I do think that this machine now works just fine, but there are one thing that we have forgot to address, and that is the strange measurement we made on the A14 address line. Yeah. What we see here is that the memory chips on the newer C64 has no direct access to the address bus at all. And that is because the 74 LS257s, the 373 and the 258, they are now integrated into the PLA. So there is no multiplexing and switching of the chips outside of the PLA. So could this strange behavior we see here then be caused by a faulty memory chip? Yeah, probably, because we know nothing about the inner workings of the PLA, but we do have to assume that this PLA works about the same as the old ones, and that they in addition have this logic. And this logic, of course, has to work the same in some manner behind the scenes. But we really don't know anything about that. And what we also see here is that this measurement we see here can actually be caused by bad triggering or bad measurement on the scope meter. And we actually have probably 3 pictures of the same situation here, because this is what we see on a fully working C64. And this is not the same that we see on the Regal scope, and these measurements are taking at the same time. I just changed the probe, so it's taking on the same working C64, running the same nothing as the other picture. So both of these should display the same, but they are not. So is this due to bad sampling, bad triggering, or that we are seeing some, just part of this window in here? It could be. But even though I think we can draw the conclusion that the Regal scope gives us the best picture of what's really going on these buses. And I will also try to make a sampling with this with a high quality analog scope to see how that compares with what we are seeing on the scope meter and the Regal. But that will be a working for another video. Yes, hope you enjoyed this C64C repair. I at least have learned a lot about the internal architecture of the C64C. As I've said before, I was not a repairman for Commodore back when the C64C was launched. Commodore consolidated their repair service and centralized the repairs earlier than the release of the C64C. But I have done some fault finding on C64Cs before, but actually mainly on the versions with the long board inside and not the short board. So this has been an experience for me too, and I hope that we have been able to learn something together. And the next project will probably also be a short board, if I can find something that does not work. In the start of this video, I presented 2 machines that we should look into, but actually when I was working on this one, I plugged in the other machine too, and it was working. And this is a revision 3 machine. So what we will be doing in the next part in this series, I'm not entirely sure yet. But of course it will be a C64 in one kind of or another. So, thanks for watching. Hope you liked the contents. Please hit like and subscribe. Leave a comment if you wish. I always appreciate feedback. Also, if you have something that you're not satisfied with. See you in the next one.